So two different companies are there, is number 2 and is number 1 and 2, right? But in this case, what happened? We have same is number 1. We can use the same is number. That's a IBGP connection, right? So the configuration for the IBGP, we have a router BGP number 1, right? And we have a neighbor. So I'll first put the neighbor 12.2, remote AS should be 1, exit, and router BGP number 1. Let's put it down. Router BGP number 1, neighbor, I will say the 2.2.2.2, remote AS 1, neighbor 2.2.2.2, update source flow back number 1, and I don't need to define the eBGP multi-hop command over there because by default iBGP has a TTL 255, right? So I don't need to define that thing. Router BGP number 2 or no 1. I said the neighbor 101. Sorry, not neighbor 1. It should be 12.2. Sorry, 12.1, and remote AS will be 1, and it should be have a router BGP number 1, and neighbor 101. Remote AS will be 1. Neighbor 101. Update source to back 1. Exit over there. Now in front of you, you have all configurations, right? Yes. What your sound is set up? All good. Okay, and this configurations and this configuration. Okay, so guys, try to understand. This is my EBGP session, right? This is the EBGP connection. Why I'm saying the EBGP connection? Because we have a two different autonomous system number, right? We have a AS number 1, right, and AS number 2. Two different autonomous systems are there, so that's why we are saying that this is a EBGP connection, right? It's a EBGP. And this EBGP connection, or we can also say that this is the external connection, right? Because EBGP also known as a external link, right? Whereas this is the IBGP connection we have, because all this router is belongs to the same AS number, AS number 1. So router number 1 has a AS number 1, and router 2 also belong to the same AS number. So we have a configuration over there. So this is my directly connected configuration, that directly neighborship, direct neighborship, and we have this one is the indirect neighborship. Okay, same thing with this is the direct neighborship, and this is the indirect neighborship configuration. So in the last classes we have discussed each and everything. And in EBGP, what happened? In EBGP, by default TTL is 1. By default the TTL is 1, and in IBGP TTL is 255. Tell me one thing. Tell me one thing. If I'm going to put this command on the router number 2, what will be the output of this command in the running config of Cisco CLI? What will be the output of this command? EBGP multi-hop. Here I have defined the multi-hop 2 over there, right? Manually, and you can define, as I told you, that you can define the TTL from 1 to this range will be 1 to 255, right? Exactly, right? It will become the 255. It will become the 255 TTL for this person. If you just define the EBGP multi-hop over there, the TTL will become the 255. Right? Perfect. Now, if you remember that, this, so hope this configuration is clear to all of you guys, how we can form the direct neighborship and indirect neighborship. And right now, what happened? You also need to define one static route towards this person, right? Otherwise, the neighborship will be not formed, right? Because BGP works on the TCP, and TCP need a reliability, right? Okay, so the same person should be present. If you define the default route will be not works in this case, right? So don't define the default route. Default route will be not work in this case. Now, if you remember the network statement, right? In IGP protocol, we have it advertise the route, it enable the interface, right? It join the multicast group. And if you have, or not if you have, you can say that if you are running with the EHGRP, then it put the route. First, it advertise the route. Second, enable the interface. Routing protocol. Third, it join the multicast group. And fourth, it put the route in topology. This is the network statement for the IGP, right? This is the network statement for the IGP. And because of this reason, right? Because of this reason, what happened? It enabled the interface into the particular routing protocol. And from this reason, what happened? They will send the hello packet. And once this will send the hello packet, they will form the dynamic neighborship in IGP. But in BGP, what happened? In BGP, it only advertise the route. That's it, nothing else. It's not going to enable the interface, right? If you remember that in the first, not first, on the second day of the lecture of the BGP, I told you that what happened. First, you have to form the neighborship, right? First, you have to form the neighborship. After forming the neighborship, right? After forming the neighborship, now what happened? Now we can exchange the update. Listen to me very carefully. After forming the neighborship, after making a neighborship, now we can exchange the update. It is seem like that when the two person are meeting somewhere, right? For example, this guy name is A, this guy name is B, and this person has made to the airport. What happened? If B has some newspaper, right? If B has some newspaper, and if A wants this newspaper, so first of all, A has to make a, or we can say that A must make a communication with the B, right? A first make a, or sorry, A first make establish the communication with the B. Hey, my name is B, my name is A, and B will say that, hey, my name is B. Once the once the neighborship will be formed, right? Once the communication will be formed, after that, A can say that, hey, can you give me the newspaper? So if B is interested, the B will say this newspaper to the A. So what happened? First, we are forming the neighborship. After forming the neighborship, now we can exchange the update. Now we can exchange the update. So what happened in the BGP right now till this point? Till this point, we have only learned about how we can form the neighborship. Till this point, we have only learned how we can form the neighborship. As we know that BGP has a two flavor. One we have a eBGP, one we have a iBGP, and eBGP has a two things. We can form a directly neighborship and we can form an indirectly neighborship. Direct means what? Both the person are present in the same broadcast domain. Indirect means what? Both the person are present in the different broadcast domain. Same thing in iBGP, we have a direct neighborship. Same person are present in the same broadcast domain. Sorry, both the person are present in the same broadcast domain. Indirect neighborship means what? Both the person are present in the different broadcast domain. So we are just from the neighborship. What about the communication now? How we can exchange the update? How we can exchange the update? Take example. We have a router number one, right? And we have a router number two. Okay, router number one and router number two. and this is my 12.1, and this is my 12.2, this is my 0/0 interface, and this is my 0/0 interface. And we have a one landing function /8. This is my LAN network. I'm again repeating, this is my landing function. Same thing, we have a 2.0.0 /8, and this is my also landing function. And this guy is belong to the ACE number one. We can say that this is the company A, right? ACE number one, this is the company of network homes, or we can say Cisco over there. And this is the another company, we have ISP, ACE number two, or this guy is a Airtel. So if you not provide the communication between these two person, what happened? First, we need to make a neighbor relationship. First we need to make a neighbor relationship. Either you can make a neighbor relationship with the indirect, or either we can make a neighbor relationship with the direct. But most of the time, whenever you are forming a eBGP session, most of the time, 90%, most of the time, what happens whenever you are forming the eBGP session, you always prefer the direct neighborship. So I need to form the neighborship with this which person. So router BGP number one, on a router number one, I need to say that ACE number one. This is the 16-bit of ACE number, right? You can take any number from 16-bit. The range will be 1265535, right? Nowadays in the market we have a 4-byte as well as, but we will discuss this thing later on. So 16-bit of ACE number, it will support in the 12.0 IS version. In the 12.0 IS version, the 4-byte will be not supported. I need to say that router BGP1. After that, I need to define the identifier of this guy. So BGP router ID will be 1/1, and neighbor I'm going to form with the 12.2, and remote address will be 2. That's it, right? And I need to say that exit. Same thing I need to do on the R2 router BGP number 2, BGP router ID. If you want to define the router ID, you can define the router ID, and I need to form the neighborship with the 12.1. And after that, what happened? First, this router will form the three-way handshake, as we know that because this guy works on the TCP, right? So first they will exchange the three-way handshake process, sync packet, sync plus acknowledge, and acknowledge. Sync, sync plus acknowledge, and acknowledge. Once the three-way handshake will be complete, once the three-way handshake will be complete, once the three-way handshake will complete, now the router one is going to send the first packet. The router one, this router is number one, right? This guy is in the first packet of the BGP. After three-way handshake will be completed, this is the three-way handshake, right? After forming the three-way handshake, after three-way handshake, BGP comes in the picture. Now the router one will send the first message of the BGP, the open message. In this open message, right? In this open message, what they will put? They will put the own identified information. Own identified means what? It will put the own router ID. That's a 1.101, right? They will put the own AH number. That's the AH number one, right? And they will put the own hold on time. That's a by default 180 second. Many information are present. Don't worry, I will show you each and every information. And also one more information will be there. BGP version. By default, it's 4. By default, okay, 1 minute. By default, BGP version 4 is enabled. We had a BGP version 1, 2, and 3 as class. But common thing about this version, all are classful. That's why we are not using in the market. All this version are introduced before the 1990 because itself in 1993 we had introduced the concept of class less. So guys, whatever the BGP version we had, so we had a BGP version 1. So basically this BGP has a 4 version, version 1, version 2, version 3, and version 4. This is the default version. We are not using this version because the common thing about this, all this version is class. This is my class less. What is the meaning of classful over there? It only support the classful routes. For example, if you have 1.0.0.0 slash 8, if you have a 2.0.0 slash 8. But if you have a 10.10.10.0 slash 24, it is not supported by the, this person is not supported by the BGP version 1, 2, and 3 because it's a classful. This portion, this 2% is supported by the only BGP version 4. And it's a default version of the right now in the market. I think so, as I remember, the BGP version 1 has introduced in the 90s 89, in the 90s 91, the BGP version 2, and BGP version 3 was the 1992. Maybe the one of the date will be mistake over there, but yeah, almost near around this days was they have introduced the BGP version. So this is not a new protocol, first of all, right? This is not a new protocol. This is the oldest protocol that still we are using. So can you imagine now, 90s till 2020, almost 30 years, right? And we are moving in the 2021, almost 30 years, we are still using the BGP. And till this point, no one has a protocol that has replaced the BGP. The algorithm of the BGP is so hard. BGP is the only routing protocol right now in the market that can handle huge amount of information or millions of the route they can handle. A complete internet architecture, right? Or we can see that BGP is the backbone. It's a backbone of the internet. It's a backbone of the internet. So till this point, still we are learning the BGP, right? And even the market, the complete BGP is dependent. Many of the companies totally depend on the BGP. So all this information, guys, try to understand. So right now we are going to use the BGP version 4, and you cannot change the version in the Cisco CLI. You cannot change the version in Cisco CLI. Default is 4. There's no way you have a command. I'll show you the command line as well, as don't worry. You have a command. You can go for the command line to L2 and put the command version and put the question mark. You will only have a 4 line. So all this information, right, guys? All this information I'm sending. This is own identifier, own AH number 1, and own hold on time 180 seconds. That's a by default, and BGP version. All this message I'm sending in the BGP first message type. It's an open message. Open, as the name suggests that, hey, after the three-way handshake, the BGP comes in the picture, right? After three-way handshake, BGP comes in the picture. This is the TCP guy. So first TCP will handle all those things. Once the TCP has completed, now this guy will give the task to the BGP person. So once the three-way handshake complete, now the BGP will take care of, right? BGP is in open. Open means what? Hey, now I'm ready to form the neighborship with you. But before forming the neighborship, I need to verify all this information. And all this information will exchange in the which packet? Open packet. Or we can do the first message type of the BGP. Router 2 also send the own message, right? Router 2 also will send the own open packet. And they will also put the same information. They put the own identifier. It should be 2.2.2.2.2.2. This should be 101. They'll put the own AH number. That should be 2. They will put the own hold on time. That should be 180 seconds. And they will put the own BGP version. That should be 4. So this guy will send the own open message. This guy will send the own open message. Once the both the router will exchange the open message, what they will verify? If no authentication will be there. If no authentic, if I'm not going to apply any kind of password, right? Then what happened? Router 1 and router 2 is going to verify identifier. Both identifier is a different. It has to be unique, like a OSPF. Like a OSPF, it has to be unique. In EHGRP, what happened? If you remember that in EHGRP, if the router number 1 and our router number 2 has the same identifier, I'm talking about the router ID, right? If the same identifier, they can form the neighborship and they can form the adjacency in the EHGRP. If the router number 1, if the router number 2 has OSPF is running, and if they have a same identifier, they cannot form the neighborship. Same like in BGP. In BGP, what happened? Every router has to be a unique router ID. If this process will be complete, now what happened? If the identifier will check, now the next thing what router is going to do, it will look up the this information, reachability. If the reachability is there, see, if the no authentication, go. Reachability, go. Identifier, go. Then after that, it will look up the BGP version. As I told you that you cannot change the BGP version in the Cisco CLI. By default, it's 4, right? You cannot change it. But still, they will verify the BGP version. If the BGP version mismatch will happen, for example, 4 and 3, they cannot form the neighborship. They cannot form the neighborship. Version should be seen. Version should be seen. Router ID must be different. These two things you have to always remember. Router ID must be different and version should be seen. After that, the next thing is the reachability. That's you already know because BGP works on the TCP, right? Next thing, what I'm going to verify now. In this packet, in this open message, when R1 is sending the open message to the R2, right? What happened? What ACE number they are putting? This guy is going to put the ACE number what? 1. Own ACE number. So when R1 is sending the own ACE number 1, R2, this router number 2 is going to verify with the remote ACE. Is it same? Yep. Same thing. This person is going to send the own open message. So this guy is going to put the own ACE number 2. Is going to verify with this person. Is it same? Yes. If both are same, right? If both are matching over there, It means that ACE number is also correct now. Once the ACE number correction will happen, now after that, it also going to verify, not after that, it's also going to verify the whatever the neighbor statement you're putting. If you're putting the neighbor 12 or 2, right, it will, as I told you, you have to check the reachability. That's a TCP. If you don't have a reachability, if you just put the wrong IP address over there, if you just put the wrong IP address, they still not from the neighborship. They still not from the neighborship, because every single thing you have to match over there. So after the three-way handshake, right? After the three-way handshake, I'm going to send the open message. In the open message, all information that I'm going to exchange. Now the question is that, okay, done. Own identifier is complete. Own AS number is complete. BGP version is complete. Why I'm sending this information now? Hey guys, try to understand. By default, the hold on time is 180 seconds, right? What happened if the router number one has a 150 second is a hold on time, and router number two has a 180 second is a hold on time? In that case, what happened? Router number two will negotiate with 150. Lower is more preferred. That's why we are also extending the hold on time in the open masses. So till this point, let's do the practical. Okay, then I'm coming to the next packet as well as. So this is my router number one. This is my router number two, right? And I'm just trying to form the directly neighborship, not the indirect neighborship right now. In the indirect neighborship, the same thing will be happen. Only the one extra thing will be happen, the next hop utility, right? And if you have a EBGP, then it will verify the detail value. So I'm going to make a one loop back so that it will become the router ID of R1, right? And I'm going to make the R2 as a router ID. Router ID is nothing else. It's just a 32-bit number, right? And that should be represented in the IPv4 format. And this router ID must not be reachable, right? It's not like that you have to provide the reachability of the router ID. No. On R1, I'm going to make a config to interface 0/0. IP address will be 12.1/24. Nodes are done. And I'm going to use the interface loopback number one. I'm going to make a 101.1/8 over there and do the lower save this configuration. R2 interface 0/0 IP address will be 12.2/24. Nodes are done, and I'm going to make an interface loopback number two and loopback is a virtual interface. They don't have a MAC address, and that's why we are not going to put the nodes are done. Router BGP number one, BGP router ID 101.1. I'll just capture this link. And let me do one thing. I'll just go to router number one as well as debug IP TCP transaction and debug. I'm not interested. Okay, debug IP BGP and debug IP BGP update as well as show history. I'll copy this command, sorry, debug command and paste on R2 as well as. Come back to the R1. Router BGP number one, neighbor 1202, remote edge number. Immediately what happened, this interface will be enabled in the BGP, right? And once this interface will be enabled in the BGP, as we know that they works on the TCP protocol, and they will reserve the port number 179. Right? R2. Router BGP number 2, neighbor 1I162.1, remote age should be 1. Wait for some time. It will also reserve the port number 179. And can you see what happened over there now? First, they will form the three-way handshake, right? Control M, second packet, and third packet. So can you see that the first three-way handshake will become a TCP, 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 sync. That's a 12.1. 12.2 is giving the reply, sync plus acknowledge, and 12.1 again giving the acknowledge to this guy. After that, what happened? The BGP comes in the picture, right? So 12.1 is in the BGP packet, open message, right? Stop this guy. Open this 12.1 is sending the open message to whom? 12.2, right? If you just open this packet, what happened? The Ethernet header is the source MAC address, right? Source MAC is the R1 MAC address C201. This is the R1 MAC address. C201 is the R1 MAC address. Destination C202 R2 MAC address. So if you verify this thing as well as just go to router number 1, do show interface 0/0 input BIA R1 MAC address, right? And this is the R2 MAC address. Type is the IPv4. I need to forward the packet to the home layer 3, right? So once the packet is coming to the layer 3, in the layer 3, what happened? As we know that BGP always use the unicast, right? They don't have any multicast address. So if you see, all my header is a totally unicast. All my header is a totally unicast. And by default, the TTL is 1 for what? Which guy? eBGP, right? And after that, what happened? He's saying the protocol number is what? Protocol number is TCP6, right? So I need to forward the packet to whom? Layer 4. And on layer 4, what happened? The source port number will be random, and destination port is what? 179. And if you see one thing, after what happened, I'm sending the BGP. In a BGP, what happened? The first packet is open message. This message can be changed. This message can be keep alive. This message can be update. And this message can be notification. Or right now, open message is going on. So only 4 message will be there in the BGP. What information R1 is sending, guys? Try to understand. This is the R1 packet, right? 1 minute. Let me do one thing. Not this one, not this one, not this one. So if you see, R1 is sending this packet, right? What information I'm putting? I'm putting the BGP version 4 in the open message. I'm putting the my age number, and I'm putting the hold on time over there. And as I told you, the load hold on time is more preferred, and I'm putting the BGP identifier. Anything extra information? Yeah, we have some optional parameter that I'm not interested right now. And the size of packet is a 45 bytes, right? The optional parameter length is 60 bytes. Sorry, 16 bytes. What R2 is doing? R2 will also send the open message, right? So if you see the R2, 12 right? Not a 12 is sending the open message. So now if you verify these two things, what happened? If you see, let's do one thing now. I'll open this packet over there. So I'll put the ACE number 1, ACE number 1, and this guy's ACE number 2. Okay, and I'll put the diagram in the front of you, and now you can analyze the packet. So now take a screenshot, snip. So here BGP route dynamic is BGP router exactly right, Prabhu. All cool. 1 minute. I need to remove this guy. You know, Okay. Now analyze the things, right? What R1 is doing over there? R1, right? R1 has a route ID 101, right? They have put their own identifier over there. This guy's in ACE number one. So this guy's in the, my ACE number one. BGP version by default 4 is there. And this guy's in the open master, right? In this open master, they also going to put the hold on time. So this packet is sent by whom? This packet is sent by the R1. R2 is also sending the same packet, right? In this one, what happened? They put the own identifier, hold on time, my ACE number, and version. Which matches? Everything is correct, right? Everything is correct. Now they are forming the neighborship. That's why. That's why they are forming a neighborship. And after what happened? Once this guy will be exchanging the open message, this open message is what? This open message is used for neighborship, like a hello packet. Once the neighborship has formed, then new packet keep alive to maintain the neighborship, like a hello packet. So basically, what happened in your IGP protocol? We are using the hello packet to form the neighborship, and we are using the hello packet to maintain the neighborship. But in BGP, we have a two separate packets. This guy is just going to form the neighborship. That's the open message. And this guy is just going to maintain the neighborship. And this keep alive message will be exchanged at every 60 seconds. So if you see, do we have any message in the keep alive? Any information? No, I don't have any message. Sorry, I don't have any information over there. Keep alive means I'm just going to send the empty packet. Empty packet is there, right? It's totally a empty packet I'm sending. That's a benefit, right? This is the benefit of the BGP. So what happened by using this, by sending this periodic packet at every 60 seconds, and this is the empty packet, we don't have any information. I'm not going to waste the bandwidth. It avoid the wastage of bandwidth and improve the. So as compared to processing the 100 bytes of packet, that's a IGP, almost 100 byte. Now, how much amount of byte I'm going to carry on the 19 bytes over there only? Can you see the packet size 90 bytes near around? As compared to processing the 100 byte, how many bytes are, and this 100 bytes of packet I'm going to process at every 10 second, right? In the not 100 byte, actually it's a nearby 90s bytes are there also, right? But this 19 byte is going to processing at every 60 second. So can you see the difference is happening? I'm not going to put the burden, right? I'm not going to put the burden on the media. I'm not going to put the burden on this physical link. I'm totally removing the burden from this physical link by exing the keep alive packet. After the forming the neighborship, this open massive will be never exchanged until or unless you are not going to reset the neighbor. Until or unless you are not going to reset the neighbor. This open message will be never exchanged. Open message is only for one time. After that, keep alarm will be exchanged as a periodic way. Can you see that? Keep alarm, and after some time, keep alarm. And again, this keep alarm message is a reliable, and that's why you have a acknowledge packet. So now if you see one thing, as I told you that this BGP router has formed the neighborship, right? This BGP router has formed the neighborship. So if this router has formed the neighborship, they will maintain the neighborship. And how do I check the neighborship? We have a command show IP BGP summary. We can check the neighborship. I will explain you each and everything. No worry about that. I have a neighborship, right? So if this router is forming the neighborship, so what happened? If you remember, I told you that first they will form the three-way handshake, right? A TCP connection. What is my TCP connection now? It should be there, right? If you exchange the three-way handshake, the TCP socket should be there, right? TCP connection, TCP socket should be there. So if you don't see the TCP socket, you can see show TCP brief. We have our TCP information as well as. So what this guy is saying that, hey, my local address R1, and that is going to use the random port number. My foreign for R1, the foreign address is 1202, and that has going to use the reserved port number 179. And the state is, this is the TCP state, right? The established. So how many TCP information we have? If you just put the command show IP BGP neighbor, can you see all this TCP information, right? This information, packets, this information. Where should I store this information now? Can you see this amount of information that you are forming after the BGP? And these all my TCP session information. This all my TCP session information. Where should I store this information? Where should I store this information? Because if you're putting this amount of in, these are my all data, right? Where should I store this information? So after the forming the three-way handshake, right? Once the three-way handshake will be completed, they will make a TCP socket, right? This is the TCP socket. And this all this TCP socket information, all this TCP information will be stored in the one database table. And that database table is known as a TCB. TCB stands for transmission control block. Each router, not each router, each neighbor has a separate TCB. Each neighbor has a separate TCB. And how do I identify the TCB? By using the identifier. So every TCB has a separate ID. For example, this TCB has ID number 1. So we have another TCB, we have another ID. And what TCB is going to do? It will maintain the information about TCP. TCP information will be there. So how many states are there, packet exchange, how many packets I have sent, every information will be there in this TCB. So if you see this TCB information we have over there, right? Transmission control block, and this TCB is identified by the TCB number. So if you see show TCP, TCB, and if you just copy this guy and paste over there and hit enter, all this information will be stored in the TCB. Can you see that? All this detailed information. So every time, guys, whenever the router will form the neighborship, Whenever the router will form the neighborship, all this information will be stored in the transmission control block, this TCP information. And each TCP has a separate identifier, and that identifier is known as a TCP ID. So if the router has a two neighbor, listen to me, if the router has a two neighbor, for example, router number 2, 1 and 3. So router number 2 has a two neighbor, one this guy and one this guy. So they have a two TCP session, one TCP session, sorry, one TCP block and another TCP block. And both are independent to each other. All clear? So how many packets we have till now? We have seen the keep alive message, right? And we have seen the open message. Open message is only from the neighborship, whereas the keep alive message to maintain the neighborship. And this keep alive message will be exchanged at every 60 seconds. One more thing that I want to show you, if you see one thing, router BGP number 1, can I change the version? I don't have ability to change the version because version 1, version 2 and version 3 is totally a class full version. We cannot use it, right? Another thing of the hold on time concept over there, what I can do, why I'm saying the hold on time message in the hold on time information open message. So let's do one thing now. I can change this guy hold on time. Okay, what's the command? Timer. So the keep alive will be I'll make it 30 and hold on I will make it, okay, come on, 90. Do clear. I'll explain you this command, don't worry about that. I'm just resetting my neighborship. So again the open message will be exchanged, right? Because after the open message will exchange, they will send the own 90-second hello hold on time, right? So now the router 1 will send the hold on time with the 90-second, and this guy will send the hold on time with the 180-second. So what router 2 will do? It will negotiate with the 90s. So if you see on a router number 2, show IP BGP neighbor, what happened? The default is 180-second, right? What I'm doing, I'm negotiating, right? On a R1, if you see the same command, show IP BGP neighbor, what happened? This guy is saying that, hey, hold on time is 90-second and keep alive is 30-second. And this is the configure hold on time, right? So R1 is sending what hold on time value is a 90, and what R2 is sending 180. Which one is the lower? 90 is the lower. So what R2 is saying, hey, let's negotiate with the 90. Lower is hold on time is more preferred, right? Lower hold on time is more preferred. Now the next thing is that let's do the same thing. I can go to router number 2 and router number 1 and say that, hey, router number 1, your BGP router ID is what? Same router ID. What happened? Now this guy has a router ID 2.2.2.2.2, and this guy has a router ID 2.2.2.2.2. As we know that in the open message, we are also exchanging the what? Router ID. BGP identifier is known as a router ID. BGP identifier is known as a router ID. So we are exchanging the router ID. Same. What happened? Just because of what? Which message I'm receiving? Notification message. Notification means what? On a Facebook, what happened? You got a notification, right? On a Facebook, what happened? You get a notification. What is the meaning of notification in the Facebook? If someone is trying to, sorry, if someone has uploaded the videos or like photos, they tagged you, and even if someone is making a comment on your photos, what happened? You got a notification. Notification means what? Something has changed. So how many messages we have seen till now? Open message we have seen that it is going to form the neighborship. Keep app is going to maintain the neighborship. And notification means what? Something has a problem. Something has a problem. What problem is there? Identifier is wrong. So based on this debug message, you can easily troubleshoot your network as well as. Based on this debug message, you can easily troubleshoot your network as well as. So let's correct this thing. I said the BGP router identifier is a 10101. Now they will form the neighborship, right? 100%. Let's make do clear IP BGP strict hard. Now neighborship is getting up, right? And now let's do one thing. Do show run section BGP. If you see, my neighbor is 1202, right? And can I ping the 1202 from R1? Of course we can ping. Let's do one thing now. I'll say this guy, no neighbor 1202, and I'm going to change this person with a 1203 now. Same AS number. Will I form the neighborship now? Of course not, right? Can you see this configuration do show on section BGP? We have already given the command over there, neighbor 1203, right? Remote AS number 2, but I am not able to form the neighborship. Can I ping the 1203 now? Do ping? No, we can't. So do we have a, I don't have a reachability, right? So I can't form the neighborship. So even if you have a wrong IP address is configured, you are not able to form the neighborship. Let's correct this thing. I say that, hey, my neighbor, no. I say the now neighbor will be 12.2, the correct IP addressing, but I'm going to use the wrong ACE number, now 3. So what happened? Now try to understand. This guy is saying the open message. In this open message, what happened? He's putting the own each number. What? Own each number, he's putting the 1. So when this guy is saying the own each number to this guy, R2, what R2 is doing? R2 is saying the own open message. And in this open message, what R2 is doing? R2 is saying the 2. So is it matching with this person now? No. What message they are giving? Not actually sending 1, it's sending the 3. He's sending the 3 open message, right? What message they are giving? We are in the wrong age. Which message I'm going to generate on the BGP? Notification, right? A problem is there, right? So guys, this kind of troubleshoot you will face in exam, right? And even what happened right now, let's correct this thing. Even what happened if I'm going to block the 179 port number, then will I form the neighborship? Of course not. If I'm going to use the ACL, and through the ACL, if I'm going to block the 179 port number, even you cannot form the neighborship. All clear? Now, next thing is that, so we have done with the neighborship. If you see, we have a neighborship right now. Okay, I have a neighborship right now. We're all good. What I want to provide the communication between these two persons. So if you not provide the communication between these two persons, what happens? You need to advertise this route, and you need to advertise this route. And how do I advertise the route in the BGP? Simple, network statement, right? Simple network statement. But Do you know one thing, guys? The BGP network statement, right? BGP network statement, network command of the BGP is totally depend on the two-person. One, auto summary, and second is no auto summary. The network command of the BGP is totally depend on the two-person. One is the auto summary and one is the no auto summary. The syntax is very simple of the network statement. You just need to put this command router BGP1. I see the network and need to define the network ID, or either you can use the this statement. There's two commands for the network in BGP. Now, the first command is going to represent for the class full route. The second command is going to represent for the class full and classless. In BGP, one thing keep in the mind, in BGP, we always match exact match. Exact match in the sense of what? If you have a 1.0.0.0.0, this network ID is present, then you have to use the network statement like this. This is the class full. We can do that. But if you have a 1.1.1.0/24, then you need to use the statement because this is the classless now. Now this is the classless. For the classless, we need to use the 1.1.1.0 mask slash 20. So for the class full order, you can use this statement, right? And for the classless, you can use this statement. If you are going to, for example, if you are going to use this statement 1.0.0.0, network will be not advertised. If you have this network is configured on the router, right, this will be not advertised. So that's why saying that you have to match the exact match. Exact means what? Whatever the IP is configured on, not whatever the IP, whatever the exact route are present in your local routing table, you need to advertise that route. That's why it is known as a NLRI. In BGP, the network is known as a NRI. In EGRP, 1.0.0.0.0 is this is what? This is just a network, right? But this is also known as a route. This is also known as a prefix. We can say that LSA, or we can say that NLRI. Network layer reachability information. Why I'm saying the network layer reachability information? Because we need to perform exact match. So BGP network statement is totally relying on what? The BGP network statement totally relying on the auto summary concept and no auto summary concept. If your auto summary is enabled, if your auto summary is enabled, no need to perform exact match. If your auto summary is disabled, we need to perform exact match. So if you see right now, by default, auto summary is disabled in 12.0 iOS version and in the 15.0 iOS version. By default, auto summary is disabled. Doesn't matter which version you're going to. If you're going to use the 12.0 iOS version nowadays and 15.0 iOS, in both the case, what happened? Auto summary is disabled. So if the auto summary is disabled, what happened? You need to perform the exact match. So guys, if you have a look over there, what happened? This network, if you just see on R1, if you see, I'll put the command debug IP BGP update and debug IP routing. If you go back to the R1, this network, right? If you see this 1.0.0/8 is there, right? This is the classful. For the classful, what happened? I can use this statement 1.0.0.0. I can use it, right? No issue. If you see, do debug IP BGP update, right? I can put the network 1.0.0.0. Router 1 will advertise this route. Is sending, right? And in the update packet, this is the update packet. In this update packet, I'm going to put the network stream 1.0.0. And R2 has to receive. So R1 is sending this update packet to the R2, right? And R2 has to receive this update packet from the 12.1, right? And this guy will be at this route in the routing table. Even if you see, if I'm going to say that, let's create another loopback on R1. This is also classful, right? So we have another loopback. We have 1.0.0.0/8. We have 11.0.0/8, and we are going to create the 50.50.50.50/24. So if you see, I have used this system in network 1.0.0. R1 is advertising this route to the R2, right? And even if you put the router BGP number 1 network 11.0.0.0 and mask 255.0.0, even you can use this statement, right? This is the one syntax, and another syntax we have this guy. So we are performing the exact match, right? Can you see the same route information is present in my routing table? /8, because auto summary is by default enabled, right? Sorry, by default disabled. So if the auto summary is by default disabled, if you see, if the auto summary is by default disabled, we need to perform the exact match. Exact match you have to do from the routing table, right? So if I'm going to say that network 11.0.0.0 mask keyword, I can advertise this route. I'm sending the update packet, right? And R2 will receive this update packet, and R2 will maintain this information in the routing table, right? So either you can use this statement or either you can use this statement. Both are correct because both are classful. But the issue is coming if you create the another loopback, interface loopback number 3, 50.50.50.50/24. And let's do one thing. I say the router BGP number 1 network. Is it worked? No. Can you see is there any update is happening over there? No. My debug is enabled, right? My debug is enabled. So if you put this statement, our router 1 sending the update packet, right? But I'm putting the 50.0.0.0. Why the router 1 is not sending the update packet? because it's not matching. I'm coming to the point, Anjano. Just give me 2 minutes. No auto summary. What if you see the no auto summary? No auto summary is enabled. That's auto summary is disabled. That's the meaning of no auto summary. It's disabled right now. It's disabled right now. Your question was something like, what happened if the auto summary is enabled? That I'm coming to the point. Just give me some time. So what happened as a network 50.0.0.0, right? I'm not advertising a route because I'm not doing the exact match. If I say the network, take example, and mask I say the 255 because according to my routing table, it is there /24, right? Still not sending any update packet. No update. Because my routing table is saying that do show IP root connected. What is saying that, hey, network should be 50.50.50.0 mask. The same information there, right? /24. Now, after putting this statement, router 1 will send the update packet. Exact match from your local routing table. So how many statement I did over there? Can you see? I did this statement now. I did this one. I did this one. But both are not work. Both are wrong command. This one is a correct one because this guy is going to match with the from the local routing table. So if this guy is going to match with the local routing table, now he's going to send the update packet, right? Because by default, auto summary is disabled. And if your auto summary is disabled, you need to perform exact match from your local routing table. If auto summary is disabled, you need to perform the exact match from your local routing table. And this information will exchange in the which packet update. So basically your update packet. So can you type? I'm coming to the point. Just give me a just give me some time and just give me 10 minutes. Okay, I'm coming to the point of auto summary concept as well as. So this is your update packet, right? That router one is sending, right? This update packet that router one is sending. This update packet has categorized in the three ways. Not three ways. We can say that we can partition this update. We can split this update packet in the three portion. The first portion we have a NRI, not NRI, path attributes. Second portion we have with drawn verb, and third portion we have path attributes node. Whenever like next hop, next hop is a one of the attribute of the BGP. Withdrawn routes, In normal update, NRI means what? NRI is the, we can say that this NRI is furtherly categorized in the two ways. This NRI is further categorized in the two ways. One, prefix information and prefix length. Prefix means what he's talking about the 1 or 0 or 0 or 0. Prefix length means what he's talking about the subnet mask information. Network. So this is the structure of the update packet that you will see. So NRI is what? It's a network layer reachability information. Network layer reachability information. This NRI is categorized in the two portion, prefix and prefix length. Prefix means for network and prefix length means subnet mask information. So if you see, whenever the router one is sending the update packet, also I'll just go on router number one and I'll create a one more loopback, interface loopback number 5. That's a 5.5.5.5.5/8 router BGP number 1 and network 5.0.0.0.0. Send the update packet. And next hop information I'm putting, this next hop information is a BGP attributes. One of the BGP attributes, we have lots of attributes. Okay, so if you see the BGP update message, this is the totally unicast packet, right? 12.1 is sending the packet to the 12.2. R1 is sending the packet to the R2, right? BGP update message. So what happened? We have a withdrawn routes, it's set to the 0 over there, right? So it's a top one. So here I made a mistake. I made a second portion. So it's a top one. Okay. Then after that, we have a path attributes. The path attributes is nothing but it's just a next like extra information. This is the extra information about the route. This extra information is used to manipulate the path. We'll discuss this thing almost. We have a 5 to 6 hour of lecture, 5 to 6 hour of the lecture on this attributes. Don't worry. So these are the extra information. So one of the extra information in the next talk. And then after that, network layer security information 5.0.0/8 prefix length, that's subnet mask information and the prefix. There's two portions, prefix and prefix length. So what we don't know is what 0, right? So if you do one thing, if I'm going to say that network on R2 interface loopback number 5, I said shut down. So if I'm going to shut down this loopback, what happened? Now this guy is sending route 5.0 is down, right? In the BGP, no valid path for the 5.0.0.0, unreachable, right? I'm sending the update packet. In this update packet, what route I'm putting? 5.0.0/8 unreachable. So now R2 will receive the update packet from the 12.1 and he's going to put the withdrawn route information. So if you see, when R1 is in the update message to the 12.2, now he's sending the withdrawn routes information. In the withdrawn routes, he's going to put the 5.0.0, and in the withdrawn routes, they don't have any path attributes information. In a withdrawn routes, they don't have any path attributes information, right? Withdrawn routes means what? Just withdraw it, remove it. So so what happened? So when R1 is saying the withdrawn route information to the R2, right? When R1 is saying the withdrawn route information to the R2, R2 has to remove this route from the routing table. Delete this network. Withdrawn, delete this network. Now, let's coming back to the router number 1. And what I told you that, let me move the no shutdown. And if you see, I'm going to create a one more loopback. right? I'm going to create the one more loopback number 10. I said the IP address will be 20.20.20.20/24, right? And by default, if you see do show IP protocol include auto, automatic summarization is disabled, right? And if the auto summary is disabled, you need to perform the exact match, right? If your auto summary is disabled, no auto summary is there, right? Right now, so same thing is happening, right? No auto summary is there. If you see the configuration, do show run section BGP. If the no auto summary is there, what happened? You need to perform the exact match. So right now, tell me one thing. If I have created the one route over there, if you see do show IP route connected, I've created the one route, right? 20.0/24. So tell me if I'm going to put the router BGP number one, can I advertise this route? No, right? We cannot do that because auto summary is disabled. If the auto summary is disabled, we need to perform the exact match. So do you know what happened? Let's remove this command and I see the auto summary is enabled now. If the auto summary is enabled, and now if you see do show IP protocol include auto, now auto summary is enabled, right? And do show run section BGP. And now if I'm going to put the 20.0.0.0, that is actually, if you see do show IP route connected, it's a /24, right? Do you know what happened? Router 1 will advertise this route. Because if your auto summary, if your auto summary is enabled, no need to perform exact match. So tell me which one is the better, this one or this one?
No to summary.
Why?
because it will support both classless and classful.
Exactly, right? If you see what happened, see, you know, on no auto summary, what happened? We are able to advertise the route. We have a flexibility, right? We have a flexibility. You know, no auto summary, what happened? We need to perform the exact match. We need to perform the exam. That's not a flexibility. But in auto summary, we have flex. We can put the network to 20.0.0 and we can advertise. But the problem, you know, what happened? On R1, this should be a /24. And what is the behavior of auto summary? Class fill. So now what happened? /24 is now converted into the /8. How I'm receiving the information, bro? I'm receiving the information /8, right? So I'm going to add this into /8. So guys, that's why auto summary is disabled in a BGP by default. By default, auto summary, sorry, by default, that's why by default auto summary is disabled in the BGP. If you're going to enable, they will convert the classless into the classful and they will does not support the classless information. So this is how your BGP network statement will be work, guys. Many of the times I'm telling you, person does not have an idea of the network statement. They are just putting a network statement there, that's it, nothing else. But they have a different work over there. Oh, clear now? Thanks, Samson. I'm telling you guys, I'm literally telling you, if you just have an idea of neighborship of the BGP, right? If you know the how to form the neighborship in the BGP, and if you know how to advertise the route in the BGP, your almost BGP is clear. because many of the person, I have seen many of the person, they don't know how to form the BGP membership. And if they know the how to form the BGP membership, then they don't know how to advertise the route in the BGP. All good? Anyone has a questions till this point? Any question anyone in the packets tabs or in the network statement, you can ask me now. I'm done for today. So tomorrow we'll go through the BGP states as well as, okay. Oh, thanks. Don't worry, we have more in classes. That's what I'm saying. In the night class is very good for me when I have a better time to clear all the concepts. Okay, so guys, see you tomorrow. Okay, and do the practice of this thing. And if I'm telling you, we have a lots of concepts of BGP, right? Nice log out something in BGP. Thank you so much, guys. Okay, so we'll do the BGP tomorrow again, and tomorrow we'll go through the very much detail about the states, right? So I'll explain you the finite state machine of the BGP. It's a awesome state, right? If you understand this thing, then all the CCNA level concept is clear to all of you guys, the BGP, right? Then we'll go for the much and much detail of the BGP as well as. Okay, so do the practice. Let me know if you have a question. Always remember one thing: you have to do the exact match in the BGP. Always remember one thing: you have to do the exact match. If you know this thing, that's perfect. So please upload so that I can update my notes. Then, definitely, I'll upload right now. Okay, don't worry. Okay, so good night, guys. Bye bye. See you tomorrow, same time. Okay. Good night. All. Thank you. Thank you. Thank you. Thank you, guys.